here we go, 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 here we go.
Hello, welcome to another episode of Containers from the Couch. I am super excited today because we get to talk about Linkerd and Kubernetes, and I like those things. And so anyone watching, feel free to ask questions, obviously, like usual. Let's have a conversation and learn some new things. Today, Sheetal on my team at AWS is joining. Hi, Sheetal.
Hello. Yeah, I'm excited to be here. I think this is my maiden appearance on CFTC.
It is, isn't it? I thought we had you on another show.
No, this is my first appearance, and I'm really excited to be opening with Justin and Jason. And guys, please bring on your questions, and we are as well excited to learn Linkerd.
And yeah. Sheetal's been doing a bunch of work with networking for multiple things. Multis just launched for EKS, which was a huge thing for anyone that had pods that need multiple IP addresses. There was all this like great networking expertise that you brought to that project and to the experience that I think it's great to have you here for Linkerd, which is kind of a networking stack, kind of a, it's in this proxy sort of like how do applications talk to each other. So Jason, tell us about yourself and what you're doing and what Linkerd is all about.
Yeah, awesome. Well, yeah, starting off, thanks for having me. So I'm Jason. I'm a technical evangelist with Buoyant. We're the company that does a lot of development behind Linkerd. For those that don't know, Linkerd is a service mesh. So it's kind of a longer explanation, but a service mesh is essentially it's a thing that you put on top of your Kubernetes cluster, where you sit a little load balancer beside every application instance that you've got in Kubernetes. And then that load balancer will handle the traffic to and from your application and allow you to do some kind of cool stuff, right? So when we talk about, when the folks over at Buoyant talk about service meshes, we generally talk about it giving you features that fit into three big buckets, right? Like, so security, observability, or reliability, right? Where, you might want MTLS or, authentication or something enforced by this proxy instead of by your application. Same thing, right? Like if you wanted to have standard metrics for every app, right? Instead of going in and, writing a library, a shared library that folks might use, or pushing your app developers to put like a /metrics endpoint on every application, this proxy will instead, just sit there beside your app, automatically gather metrics about how it's operating, give you some details about, what services are talking to who, and then allow you to kind of see some of those metrics.
And just my clarity around, I do have a little bit of echo from you now, Jason. I don't know, that didn't start before, but it just comes a little bit. My understanding, like I love to describe service meshes as like load balancers are a thing everyone understands, right? You can have a server-side load balancer, which takes all of your clients on the bottom and funnels them to like a point. And it's like, that's how you access this thing. And client-side load balancing just flips it, right? It takes your load balancer by your client essentially, and then routes it to all the different endpoints that it can go. So it just flips that triangle of where the load balancer sits. And then if you put these tiny load balancers next to everything, you can do those things that typically were centralized for, hey, I need centralized authentication. I need, something that like an ingress controller or something is going to collect things from external sources that maybe you don't control. But inside a cluster, it's a great way to just say like, hey, I have a lot of things to talk to. And service meshes come into play because they orchestrate all those things. And you get the mutual TLS and you get the observability and all those extra benefits.
Yeah.
Hey, Jason,
right.
I think maybe you would want to also talk about the north-south and the east-west traffic, and how does Linkerd plays a role here as well.
Yeah, absolutely. So just to what Justin, you were saying first, right? So when you think of all those little proxies all talking together, right? Like that's where the mesh concept comes from, right? Because it's your mesh of services where the proxies are deciding like, or at least giving you some enriched stuff around that traffic. And then Sheetal, in general, and we just did a thing with Ambassador for the CNCF the other day, right? So an ingress generally is like, hey, traffic from the world into our Kubernetes cluster goes through an ingress. And we generally consider that like north-south, because if you're like to draw it on like a diagram or a whiteboard, right, you generally put the internet on top, and then it would hit like the AWS load balancer, then the ingress, then go to the service, right? And Linkerd is focused not on the north-south traffic, but instead on what we call east-west traffic exclusively. So once you're inside that cluster, or even between clusters where you want to have all that traffic in your mesh, right? That serves the service communication. That's what we call east-west, and that's where Linkerd gets involved. Does that make sense?
Yes, perfect.
Awesome.
Shout out to people watching Hyperint. Glad to see you here. I have questions for you. I'm gonna text you later. Anyway, there is always those concerns inside of any infrastructure, right? Because you want, not only the traffic needs to get there reliably, and Linkerd and service meshes can help that with loopbacks and try again sort of things, but also like the security aspect of like Kubernetes has a flat networking structure, so any endpoint can talk to any other endpoint, but that maybe isn't what you actually want. If you have secured endpoints or something at the network layer that you're like, hey, actually, I want to verify that only certain services or certain pods can talk to my service because I don't need to be open to the world. And that least privilege model isn't built into Kubernetes. There are pod security policies, which are now deprecated. There are things that like kind of did that by default, but at the networking layer, you really had to look at either a CNI provider or a service mesh to do that, right?
Yeah, totally, right. So just to expand on this a little bit, so with Linkerd 2.11, we're going to add in, so let me step back, right? So you think of CNI level stuff versus service mesh level stuff, and I'm going to get boring, but this is where you talk about like the OSI model, right? So we think of like layer 7 as like application traffic, like what's happening with our applications, what endpoints, where's the, authentication token gonna come from, whatever, right? Like that's our layer 7 stuff. And then below that, the CNI looks at, right, like layer 3, layer 4 stuff, right? Like that, can this IP address talk to that IP address stuff? So Linkerd or any service mesh, right, like is never going to be a substitute for that, like, hey, I have a firewall that literally is going to block apps in one namespace from talking to apps in another, which you can do with a CNI that can do policy enforcement, right? So like Calico, Cilium, I'm sure there are others, right? I'm just not super deep into CNIs. That being said, with Linkerd 2.11, our next release of Linkerd is going to be the first one where we put in policy. And if you go look at the current Edge release, you can actually see some of that stuff where you can say, hey, like this app is willing to accept traffic from these apps, right? Or components like that. Does that make sense?
Totally. And I think the question a lot of people probably have is like, when should I block something in which layer, right? Like is this, do I need this blocked in my CNI in layer 4? Or do I need this blocked at the application layer in layer 7? And do you have a comment on that or general advice?
I have a comment and advice, so but 2 bits, right? So the first thing I'd say is before you listen to me or any other person, like try what works in your environment, right? Mm-hmm. Like, and obviously decide for yourself, but not that I think people are going to take my word as some like heavy thing. But the other thing I'd say is, what can you do, right? So say you're using something like Flannel as your CNI and that's required by your Kubernetes environment, then like the mesh is definitely the right place to do it. But if you've got like a robust CNI that respects network policies, like that's a great place to put stuff. So find out the pattern that is least effort for your organization, go down that road and start there. So I would default to doing it the CNI if I could, and then I'd go with the service mesh, if I couldn't. Or if I had some other specific reason where, I really wanted to do it at the application level. So that was a lot of words for I'd prefer the network level all the time and the application level if I had to.
Listen, can we take a segue into the 3 pillars of the observability and how Linkerd actually helps with the observability and a little bit more details of what actually it does at an architectural level and how it does.
Yeah. So like I'm embarrassed, but I don't actually know. I remember vaguely what the 3 pillars of observability are, but it's been a while since I've looked. But I can tell you how Linkerd interfaces with it regardless.
Yeah.
Right. So what Linkerd gets you, and like, so stepping back a bit, right? Like I came into Kubernetes from Cloud Foundry, right? So I'd been helping run like a platform on Cloud Foundry, and it was great, right? But I had to push on a regular basis to get, application teams to instrument metrics and do it in some sort of common way, because like we needed some way to judge applications like in a holistic fashion, right? Like, did your change make things better or worse, right? And like, I wouldn't necessarily know, and could I trust the metrics that you provided, and all sorts of other stuff in that space. So what Linkerd does is it saves your developers a bunch of time, because instead of writing that like common plumbing code, like, hey, how am I going to do service discovery? How am I going to do, service discovery is generally pretty solved in Kubernetes from like a, hey, hit this URL and go. But like there's more to talk about there that I'm going to leave alone for right now. But like metrics, or what paths in your API are being exercised at any given time, or, I guess that's really the big one, right? Like the ability to see how do your apps talk to each other inside your kube cluster, and then see how do those individual conversations between the apps perform, and when are you starting to get failures. So what Linkerd is going to get you for every application, you're going to see success rate, you're going to see the latency by latency bucket, and you're going to see the current saturation.
And also the logs, right? If you want to.
Well, so you don't get logs from Linkerd. What Linkerd can do, right? What Linkerd can do is you can actually tap the traffic in between 2 proxies. So you can get the metadata about the conversations between your applications, and you can send that off to a logging solution.
Correct.
But Linkerd itself isn't going to, it only through tap are you getting details about.
And going right back to what we're talking about with policy, like those metrics and like information that you want, I could see a TCP reset between 2 endpoints if I'm doing it at layer 4, but I can actually see like a 400 or 500 application, return if I'm looking at the layer 7. And so those are 2 different things of like, where do you want those metrics? I could get latency between endpoints on both sides of that. I could do it at layer 7, I could do it at layer 4, but I can't get what paths are being used for the HTTP. Like there's certain things you can only do at layer 7. There's certain things you can only do at layer 4. So this common like, hey, what do you want out of it? Like that's really the important question of where are you doing this policy enforcement? Where are you doing this metrics gathering? So yeah. And with that, let's actually just dive right in. I want to see like getting started. I know you have a demo for us. Like let's set up Linkerd and just see how we would install this on an EKS cluster and start running with it.
Yeah, absolutely. So I'm basically gonna exercise the Linkerd getting started guide. So I'll put this in the chat here, and maybe y'all can send it out to the audience. But I'm essentially gonna follow through the Linkerd getting started guide as is, right? So I've already gone and set up an EKS cluster that I'm using, and we're actually gonna start using Linkerd.
Can you blow the font up a little bit? Or no, we can go back to the terminal. It's fine.
Sorry. So to start off, I'm just going to go pull down the install script and get the Linkerd binary, which I'm actually lying about. I already have Linkerd installed, but we can go ahead and check it.
No better package manager.
There you go. I see I'm at Linkerd version. Sorry, one sec. I've got a laser pointer that I try and show off every time I can. Ooh. So I'm currently at stable 2.10. And we're gonna install an EKS. So
now wait, the real important question is the laser pointer part of Linkerd? No, I'm just kidding. It's a new feature in 2.10. This is amazing.
So the first thing I want to do, right, like, because we're in EKS, so do I have the right permissions? Like, can I actually do this install? So we've got Linkerd check with our pre-flag where we can just validate that this cluster is a good target. It's going to do a bunch of things, and ultimately we're going to get our green check mark, which is good.
And
so
there's nothing more cloud native than emojis in your terminal.
Oh,
that is like the benchmark for like, are you cloud native or not? It's like, do you have check marks and emoji directly in terminal from your CLI? It's critical.
Absolutely. And Absolutely. And then do we template YAML? Yes. In fact, we do.
both are you're in. This is great. And for anyone that doesn't know, Linkerd is CNCF projects. It's been around for a long time, and I installed it and used it way back in the early 1.0. Actually, I think it might have been pre 1.0 when it was node-based proxies, not pod-based proxies. And so the older proxy version, and there were benefits and pros and cons to that model as well. But also, like, Linkerd 2 switched to the new proxy, and now it is those sidecar pods with proxies and everything else. So, but for anyone else that's like, you want to run some of this yourself, if you have multiple environments or on-prem or something, Linkerd, like this pre-flight check and just like an install command is pretty amazing, just to like, you're done, right?
Yeah. So actually, just on that CNCF front, we graduated 2 weeks ago from the CNCF. So we're, I think, the 6th graduated project or something, and which is pretty big from our side.
Yeah, it's awesome.
So we've got Linkerd install, right? So this is the command that's going to generate a bunch of YAML. If you're using Linkerd, you can install with either the CLI or with the Helm chart. Both the CLI and the Helm chart use the same YAML templates. So if you set up an argument for the Helm chart, you can use it with the CLI and vice versa. So just running the command real quick, it's just going to jam out a ton of YAML, right? So this is your Linkerd template that if you wanted to save it off somewhere, feel free. We're going to go ahead and pipe it right over to kapply-f and actually install Linkerd. So this is creating Linkerd in the environment. So as of Linkerd 2.10, we've broken up Linkerd into like the kind of minimal components you need to run. So there's the core Linkerd install, which will allow you to put that proxy in beside your applications, MTLS your traffic, get the metrics or whatever that you want to your external Prometheus. But just do the core of what a service mesh does without anything extra, right? But it doesn't come with, sorry.
I'm looking at some of those. I mean, that was like 40 things that flew by and installed them. So some of those are CRDs, some of them are actual services. I saw like the proxy injector, which I'm assuming is a mutating webhook. All of those sorts of things that comes out of the box. And like you mentioned earlier, you can template it. I'm assuming like if you need to change flags or adjust those settings for deployments, you can do that. But the default install just gives you like best practices for Linkerd, or?
The default install is, I wouldn't say necessarily best practices. If you're going to use it in production, you want to use install with the HA flag, right? So it starts off with one version of a lot of the key components, but if you're going to be going for production, you at a minimum want to use HA mode for Linkerd, right? Like you might also want to do things like, that mutating webhook, right? Do you want that to be a gatekeeper that will keep new pods from being deployed or being created if they don't get the proxy injected, as an example, right? That's a consideration that you'll want to look at like actual as you're building out your production setup for Linkerd.
Cool. Yeah, great to know. Just this is a getting started, try it, kick the tires, and understand the components. And then when you move to HA, other considerations on making sure that you don't have failures in that process.
Yeah. And
hey, Jason, can you also talk about, I guess, while we are deploying this in a production and with the CI/CD and the DevOps, what is the best way to install and operate Linkerd?
Yeah, so there's no real delta between the CLI and the Helm chart. So whichever your preferences are the same. So like if you're really into GitOps, right? Yeah. If you use Helm charts, like that's fine. If you use the CLI, like that's fine. Or just put templates. Put like your YAML template in a Git repo and use customize. Like I've got examples of both. We talked at GitOps Days earlier this year about installing Linkerd and some considerations you might have. So I can actually send you the link for that after this if you like. But there's no one recommended path basically. A lot of them work, and there was a lot of work done in like 2.9 to make sure that the Helm chart and the CLI never had any divergence, right?
And I guess the true like YOLO method is curl to bash the CLI and then curl or pipe that directly into kube control, right? Like just like 2 pipes and you're like all the way to a testing install.
Well, add the HA flag and then go nuts, man. Do it in prod. Like, why not?
Put that in a for loop and you're good. That's a controller.
Right.
So I'm derailing you so much. Keep
fine.
going.
So I just ran a Linkerd check, right? So after I do the install, Linkerd check, and anytime you're debugging, if you think you have a Linkerd issue, Linkerd check will go out and just run some tests against your environment and let you know where you're at. We had, green check mark for our status. So
I love that.
say that's good to go. And now we can do some more stuff. So the first thing I'm going to do, and you'll see it in the getting started guide, is because this is a demo and we're going to actually want to see like some nice UIs, we're going to install the Linkerd dashboard. So the dashboard is in now an extension called Linkerd Viz. So Linkerd Viz install will do exactly what we saw from Linkerd install. It will add a dashboard, right? And then we're just going to apply it. If you're using an external Prometheus, right? So another thing we tell you, if you're going to take Linkerd to production, right? Like use an external Prometheus, because the one that comes with Linkerd dashboard is an in-memory Prometheus that doesn't necessarily scale super well, right? But it's a very easy flag to just say, hey, this is the Prometheus URL. Like go ahead and do this. We've got docs on that.
And if
so
you
we
have AMP set up and running, we can just point the URL to that and then, plug that in. Does that work that way?
Can you say that again?
The hosted AWS
Hosted EM.
Yeah.
Yeah, absolutely. So it's any Prometheus URL. So it doesn't need a particular instance, and it doesn't need to be running in cluster. So I just ran Linkerd check again, and so it went through and did the check on both everything that's installed as part of the default install and then the various extensions. So the only extension we're using here is Linkerd Viz, and now I can do some cool stuff like Linkerd Viz dashboard.
Are those extensions? Is that like a repository? Or is this like crew plugins, or how do those work? I've never seen the extensions before.
Yeah, so that's new in 2.10, right? So every component of Linkerd is now a separate extension. So there are some extensions that are built directly into the Linkerd CLI in 2.10, and then there are third-party extensions. So Buoyant has released the Buoyant Cloud extension, right? That allows you to add your cluster to Buoyant Cloud, and that's an external extension that you download separately. But you basically just do it's Linkerd dash extension name, and then you add that to your path. And then it'll work as long as you've actually configured your extension correctly to work with Linkerd.
And Jason, while you're at that control plane keeps coming, can you talk about control plane components a little bit more? Yeah,
right. So that's a great point. So when we talk about service mesh, right, like it's good, at least to start off with, I always like to think of a bunch of little load balancers, or we call them proxies, sitting beside your applications. And that mesh of those proxies, that makes up what we call the data plane, right? So the plane that data traverses, that's your data plane. But then all those little components, like they need to get instructions from somewhere. And like me, a human being, or any of us, right? Like we need an interface point for those proxies. And that's what the control plane is. So the control plane offers command and control functionality for the mesh, right? As well as an interface point for human beings to interact with it. So, so that's where you're going to get your mutating webhook. It's where you're going to get the certificate generation. It's where we put things like the dashboard, right? So that you can look in and see, all right, like what components do we have? Who talks to what, whatever that is. A neat bit about Linkerd is the control plane also runs the Linkerd proxy. So we can see I've got some namespaces in this environment, and like, here we see this mesh thing. It's always a little confusing at first, but it's going to tell you how many pods are in the namespace. And out of those pods, oh yeah, absolutely.
Perfect.
So it's going to tell you there's this meshed column, right? So that's how many pods are in the namespace. And out of those pods, how many have a proxy beside them, right? So right now we see that Linkerd and Linkerd Viz have 5 and 6 pods respectively, and all of them are meshed. Cube system has 10 pods. None of the cube system components are in the mesh. We can see, inside each of those namespaces, how many of the requests are succeeding, what's our request per second, so what's our saturation, then latency by the latency bucket. All making sense so far? So we're at, 25 minutes into the stream, and we've got Linkerd up and running. It's typically about 5 minutes from starting to I'm at this point. And so this is all just like Linkerd traffic, so it's not really exciting yet. So we're going to add a broken application, and we're going to see what's wrong with it.
I love broken applications.
Awesome. Good. So we're going to start off with emoji vote. So we're going to add an app. It's called Emoji Vote. It allows you to vote on which emoji you like best. You know, I can do kget pods, or here, let's just change namespaces. So we're going to hop over to the Emoji Voto namespace. We're going to look at our pods. You know, we've got a bunch of things running. I could do, you know, K port forward, service. I think it's web dash service, and then probably 8080. That would make sense. Now, there we go. So now I can go back to that browser. So I've got Emoji Vote, right? I've got an app that's running. I could go vote on some stuff. I can view a leaderboard, whatever, right? Like this is kind of a simple Kubernetes app. If I go look at the Linkerd dashboard, I'm just gonna run that dashboard again. If I go look at the dashboard, however, I'm going to see that I don't actually have anything for Emoji Vote because what I didn't do was inject the application. So, you know, here I am running Emoji Vote. It's good, but I'm getting like word there's periodic failures with my emoji voting app. So let's fix it, shall we? I say we add Linkerd to this app and get it solved. What do y'all think?
It sounds good to me. I mean, I'm wondering when you're taking a seed round for Emoji Vote. Is this?
Yeah, as soon as possible, honestly. So what I'm going to do here, I'm going to get deployments inside this namespace. Just going to output a bunch of YAML. So we're just going to grab the YAML for the deployments inside. Oh shoot. Going to grab the deployments from this namespace and just inject them, right? So the process for telling Linkerd to put a proxy beside your pods, all you have to do is either on the namespace or on the deployment or daemon set or stateful set, whatever, is you add an annotation under the specification that says Linkerd inject enabled. So we're going to do that, but we're going to use the CLI to do our injection. So Linkerd inject on whatever's coming in from the pipe. Right now we've injected Emoji Voto. So if I do watch kubectl get pods, we're going to see in this namespace a bunch of new pods getting created, and once they're up and running, we're going to have the old ones are going to get terminated. Right now, what I didn't. Oh, sorry. Go ahead.
I love the granularity there of you can do it at the namespace level. Say everything gets this proxy. You can do it at the workload level of just saying like, hey, no, actually like exclude this. I'm assuming there's some way to like actually say my namespace has it, but I need to exclude some service from getting that. I can like add an annotation and say like, no, don't inject me. And Linkerd is looking at all of the webhooks, looking at all of those workloads coming in and then saying yes or no, do you get the sidecar? And that's where we see 2 of 2 running instead of 1 of 1.
Yeah, so it's exactly what you said. So I could put it the namespace to enable it on all of them, and then any individual workload. So again, when I say workload, I mean stateful set, daemon set, replica set. If you're using Argo rollouts, a rollout, whatever the thing is, right? A deployment, and just say don't inject here, and it won't be done. So what I've got now, I didn't modify my application. I made no changes to the YAML. I haven't created new services. There's no gateway or virtual service or big settings set up, right? All I did was added Linkerd inject, and this app continues to behave as it did before. But now, when I do my dashboard command, I'm going to see some additional information. So,
Jason, meanwhile, while you do that, can you just describe one of the pod and then show how that annotation looks?
Yeah, absolutely.
And the sidecar as well. The proxy sidecar.
Okay, describe, deploy. Let's go web.
Yeah.
Right, so it's right. Where do we have it?
Yeah, there it is.
Oh, sorry.
Couple of lines.
Oh, right there.
Yeah.
So Linkerd inject enabled, like that's the extent of it, right? And then the thing will get restarted, and then we recreate the pods.
And actually, the mutating webhook controller, which is running in the control plane, is injecting these proxies once it sees that annotation getting added. Correct?
Yep, exactly.
Yeah.
Exactly. So fire up the dashboard. And we see now we've got emoji Voto, which is cool. Let's just take a look at our workloads, right? We'll sort them by success rate, right? And we see that, in spite of the fact that Linkerd and Linkerd Viz all seem to be up and running, emoji Voto, however, is suffering some sort of frustrating intermittent error. There's 6 requests per second. There's like no latency. If I want to hop over to Grafana, I can. Let me just make this a little bit smaller. If I want to go look at this inside the built-in Grafana and Prometheus, or again, if you'd overrode the Viz install to say use my external Grafana and Prometheus, right? You'll be able to just launch this page, take a view, and see like, hey, what's going on, and see basically just they're the exact same metrics, just in Grafana, right? Which it should be your long-term store for metrics, or Prometheus should be your long-term store for metrics. Y'all have any questions before I keep going?
That link to Grafana is just right here embedded in this dashboard. You install both, and you just give an option for where they want to see it with defaults.
Yep. Yeah, exactly. So there's some pre-canned dashboards that you can import into your external Grafana instance and just start looking right there.
The only question that came to mind when you're doing the inject there is, are there any services or namespaces that people might want to exclude from having a sidecar injected?
Yeah, so in general, like I wouldn't start injecting stuff in the kube system unless you have a particular reason to do that, right? The other thing you'll want to do is when you install Linkerd in HA mode, one of the default settings is basically don't allow a pod to start if that mutating webhook, if the Linkerd injector isn't working.
It's a hard block.
Yeah, exactly. Right. Which makes great sense if, hey, this is my PCI processing app and I don't want anything running if it's going to be not MTLS because I have a regulatory requirement to not allow it.
Security and compliance makes perfect sense.
Yeah.
Availability, you have to be the judge of what you want.
Well, right. So your kube system, your CNI namespace, right? Like if you have a separate namespace for it, you don't want those to wait on Linkerd, right? So you want to specifically say, hey, please ignore the current state of the webhook for this namespace, right? So that would be the only gotcha you've got is ensure that you don't set yourself up for failure in like your critical infrastructure namespaces.
Yeah, CNI reminds me, like Linkerd has its own CNI too, right? But we are installing it on EKS, and we are using the default AWC VPC CNI for cluster networking.
Linkerd doesn't have its own CNI. Sorry.
Yeah.
What it does is it's got two ways. It's got two ways of injecting, injecting the networking config that we need to like route traffic through the proxy. So we can either give the Linkerd init container inside your pod. We can give it permissions to write to IP tables, or we can say, hey, please work with the CNI to set the appropriate rules. And that way you never have to give elevated permissions to those init containers. You can just tell it to interact with the CNI plugin instead.
Okay.
I want to leave you. We still have plenty more to demo. Go ahead and do the debug so we can see the multi-cluster and what else we can do.
Yeah. Okay. So let's look at Emoji Voto. So Emoji Voto is an app. So right away, right, I didn't do any special config. Emoji Voto is not like specially written for Linkerd, right? It's just like it's a web app with 2 gRPC backends, right? So I've got VoteBot to generate some traffic. I've got a web service. I've got voting and emoji, right? So I can now look through inside that namespace and I can see, all right, well, by things in that namespace, right, by the deployments that we're actually tracking, what's our success rate? Well, voting and web both seem to have a problem, but emoji and VoteBot are fine. All right, well, let's just, at a glance, let's go take a look at web. I see again, right, the who's talking to whom, right, and what that we've got VoteBot, and now we can go down and we can actually look. This is where it's really neat, right? You've got, let me make this a little smaller once again. There we go. You've got a list of all the live calls going on in your application, whether that's HTTP or gRPC, right? We can see every pathway being exercised inside the application, where it's coming from. So in this case, right, like this is a call from web to emoji. It's hitting the emoji list. It's happened 40 times and it's always working. I can put a live tap on that traffic if I wanted to, whatever, right? And then I can also here filter on success rate. So I not only know that like web's talking to voting and it doesn't work, or it only works 80% of the time, I can go see, hey, what API calls are you making over to voting, right? And these are in this case, this is a gRPC call, right? I can see that my call to vote works 83% of the time, but my call to voting for donut, which is obviously the best emoji, fails 100% of the time, right? So it never works when I go vote for a donut. I could tap the live traffic if I wanted to, and everything just to be clear, everything I'm doing here from the UI can be done via the Linkerd CLI just as well. You don't ever need to use this UI if you don't want to, but it's, it looks nice. So we'll go, take off this little bit here, and we'll just run a tap, right? So we're going to start capturing live traffic. So I can see, well, let's give it a minute and then we'll stop it. So we can see, the calls that happened when I pressed that tap button. So vote rainbow, okay. I had a HTTP status 200, gRPC status okay. When we voted for donut, the connection went through. I had my 200 status code, but I had a gRPC error of unknown, right? So my issue's probably over there in voting. So then let's actually just go over to voting.
And that tap's really cool because it's like TCP dump for your application, right? Like I'm not looking at the packets. I'm looking at the application logic of where these calls are coming, which you can't get at that lower layer.
Yeah. So we have a customer, they do like a SaaS-based security platform. And they were saying like, oh yeah, like we had a new service get released. We were seeing intermittent 500s, and it was like, oh, what are we gonna do? And it's like, well, I fired up Linkerd. I looked at it and like, okay, well this new one started throwing 500s like 2 hours ago. Doesn't that line up with when y'all deployed like your latest version of it? Let's go look at it, roll back. It's this API path. So like, what's up, right? Which is awesome. a nice story for solving your problems, right? Like. It's, it can be hard. Like distributed applications can be fairly difficult. So like anything you can do to, speed up that mean time to clue is handy.
Question from audience too. Is there integration with Cilium and eBPF? I'm assuming that's at like the policy level. And I think that's what you mentioned for like working with IP tables versus the policy with CNI, or is that something else? Do you know?
So there's no like specific integration with Cilium in particular, right? That being said, if you're using Cilium, we have a guide for how to use Cilium, how to use Linkerd with Cilium. So there is the CNI plugin, so you can offload writing those, routing the traffic through the proxy. You can delegate that to the CNI instead of having the Linkerd init container do it. You can also again, if you're using network policy in Cilium to say like, hey, this namespace can't talk to that namespace, like Linkerd, well, because it doesn't operate at that layer, like automatically respects it. So the two things just kind of work together without a lot of overstress. Yeah, exactly. What's going on with the donut votes? Let's find out. It's a great question, DevOps detective. Well, it turns out calls from the web deployment over to Vote Donut always fail. Right? We can actually go look at the code. So if you want to go to Emoji Voto, you can see the code. And it turns out Vote Donut has been written to only return an error. So that's our problem. But I can go say now to my developers, like, hey, folks, like clearly the API path for voting for Donut is bad, right? Here's the evidence. Please go resolve it.
I'm going to call this right now. This is a conspiracy by Big Bagel. The Big Bagel corporations don't want votes for Donut. And it was probably a pull request from them.
Yeah. Also,
it was a terrible joke. I'm sorry.
Vote Pizza is doing suspiciously well, so it could be anybody, right? But let's actually just do one more bit here because it's kind of fun to do. Port forward again. So I'll port forward that one more time. We'll go to emoji vote, right? And in spite of the fact that it's gotten by far the most votes, donut doesn't appear anywhere on our leaderboard, right? It's not really worth showing, but it's just not on there. And so the cause is there's a problem with our application. We can go vote for the donut. Ugh, 404, ridiculous. Let's get this cleaned up. So that's the short answer. That's the introduction to Linkerd, but there's like a lot more that you can do, right? So prior to this, I set up an app. I set up an app running in US Central, right? Or sorry, US East 2, right? And we, we've exported it here. And what we've got is a front end sitting there in East 2 and a back end over in West 1, right? And these services are connected. These services are connected via Linkerd, right? Where it's inside the cluster, right? Well, let's actually take a look at it. So here I've got, sorry, I'm gonna clean this up. Here I've got two clusters, right? I've got East 2 and West 1, right? And I've got a front end of a simple Nginx server and a back end of this pod info service. And if I look here, kget pods, I'm in the pod info namespace already. I can see that there's no front end running here. So same thing, kget service, right? There's no service for front end. There's nothing. It's just pod info. And then if I look at West, let's clear this up. Or sorry, I look at the US based one. I can do kget service inside pod info, and I can see two services, right? I've got my front end, and then I also have this pod info EU West service. So this looks to your applications locally, right? Like a standard URL inside your namespace. So if I go in the front end and I go curl, pod info -EU West 1, and hit port 9898, I get that return traffic of pod info. But like for me as an application, like I don't notice the difference between a local service and a remote service, right? Again, I didn't do any special configuration to make that work, right? I just export the service from one. Let's actually look at that. Right. The only thing I added to it was a little annotation that says, Linkerd exported true, and that's how we got it working. Another thing to see,
and that exports at the cluster level. In Linkerd Linkerd is installed in both clusters, and you're adding an export to one service in one cluster, right?
Yeah, exactly. So I told the West cluster that it would export services to East 2.
Okay.
Right.
So that was an additional, it was a config you told that you have Linkerd that's separate, but then you said, hey, I'm going to export some services to you. And I'm assuming the other cluster says, okay, yeah, fine, I can export some to you or something.
Yep. So as part of the multi-cluster setup, you tell one to export services, and you will allow another one to see the services that it's exporting.
And right? It's not like a cross mesh, right? Like everything sees everything. You need to basically say, I need to be seen on another cluster. Like pod info is seen on US East 2 here. You exported that information, basically.
Yeah, exactly. Another thing to look at, right? Like there's very little, like with the multi-cluster install, we have 3 custom resource definitions that got installed by Linkerd, right? Like this is like Linkerd complex mode. Linkerd simple mode over here on one cluster, right? We have 2 CRDs by default, 2 Linkerd CRDs. We have service profiles, which are a thing that you can use if you want to do retries or timeouts or get some better data about those API calls. You use a service profile. If you wanted to do traffic splitting, where that's a longer topic, you use traffic splits. So that's our implementation of the SMI spec. SMI being the service mesh interface. So that's kind of the gist of it.
And then you're explicit on the one cluster, say, hey, I'm going to export this. I'm assuming with that annotation, the controller makes one of those CRDs here that does the export, right? Like that CRD has another controller that's going to do the export to talk across clusters.
So it's just the the thing that we created, the custom object, there's the custom object is the multi-cluster link, right? That thing that tells one Linkerd cluster how to talk to or one Linkerd mesh how to talk to another, right? Like that's the CRD in play in this case, right? Like there's no, the service object that I have isn't a CRD, it's a standard service object that just happens to route instead of routing to, pods on this cluster, it instead routes to a gateway that goes across to our other cluster.
And that was my next question of, you can export that, but where's the connection here? You have to peer the VPCs or is it going over
Nope.
public network or how is that actually sending traffic from one to the other?
Yeah, so Linkerd multi-cluster is all layer 7. So it's an HTTPS connection between these 2 points, right? So there's no VPC peering required. There's nothing special in the networking layer that needs to be done, right? If I can curl from cluster 1 to cluster 2, then I can do multi-cluster, and that's all I need.
And what are like the ideal situations that someone would be doing this cross-cluster, especially like with the Atlantic latency? Why is someone, wanting to do this, or is there a way to control that for certain situations?
Yeah, so that's a great question. So I've seen a number of different use cases for multi-cluster. The 2 most common I've seen are I've got scale where I don't actually want to co-locate applications on the same cluster because I'm running too many, and I don't want to have app A living with app B for whatever reason. So I want it on a separate cluster, and so I'll use multi-cluster to segregate them between Kubernetes clusters. Right, but I still want everything to behave like a local Kubernetes service with no like external stuff to configure. The other one I've seen is shared services. So I saw a really good example of a bank that actually does, and this is an AWS, right? They set up a common cluster where they have their continuous integration tools, they have their logging tools, they have their metrics, right? Whatever that may be. They put that on a central cluster and they export those core services to their other clusters that are running in separate accounts. And then the other clusters, just again, they add their components to the mesh and then send their logs to that local endpoint for collection, right? And then everything just goes across the network and they don't have to think about it.
And is there a way that I do not want to export, right? I do not want my one mesh to be seen by another. Can I stop by doing so with some configuration?
Yeah, so you have to explicitly link clusters,
Okay.
right? So as long as you don't do that, it's not linked. And then even if you link clusters, you have to put an annotation on a service to say, hey, please export this between clusters.
It doesn't automatically
clusters.
discover.
Yeah.
Yeah, 2 opt-ins, opt-in at the cluster and opt-in at the service.
Have you seen this as like an opportunity for people to say migrate clusters on different Kubernetes versions, where I could say, hey, I have a cluster that's 118 and we want to move to 121. And typically you're not going to go 118, 119, 120, 121 in the same cluster. So you might just say, well, let's just migrate to 121, but you can export some of those services and still slowly migrate pieces and talk to the dependent services across clusters. Have you seen that?
I haven't seen anyone doing that. That does sound like a pretty viable pathway though, right? Like, because again, you could just run, all right, well, pricing is going to be on our new cluster, but we're still going to consume it from the old one. And then when it's ready, or even on-prem to like on cloud or on cloud to on-prem, right? Like you could be like, all right, well, some services are going to live here. The others we're going to.
Even all of the traffic splitting might as well be applicable here, right? I mean, even when across cluster. Like canary deployments, the traffic splitting should still work seamlessly.
Yeah, absolutely. So traffic splits work exactly as you, because it's 2 services, right?
Exactly.
Like our object of export isn't, again, we're not building new custom objects, right? So the goal with Linkerd, the whole design principle is like, it's things are already hard enough, right? Like let's not add complexity where we don't need it, right? So let's just use Kubernetes constructs first. Right, like the identity principle in Linkerd is your Kubernetes service. Same thing. Like the service discovery all relies on Kubernetes services. Right, we're not going to go require a bunch of new constructs to make this stuff work.
It's very Kubernetes native. I like that. we have like 5 minutes left, and I want to see what Linkerd does with Buoyant Cloud. I know Buoyant Cloud was launched recently, and I want to know what that integration is and what that brings to the table as well.
Yeah, awesome. Thanks, Justin. So Buoyant Cloud is Buoyant's attempt to create a managed Linkerd service. So what we've done here is with Buoyant Cloud, let me just give you a quick sense of it. There we go. All right. I may need to open this in a new tab. All right, so Buoyant Cloud, I've got, what I've got is one place where I can look at, now I'm running 3 clusters, right? I'm running US West 1, East 2, and my common infrastructure cluster. I can now get a glance, an at-a-glance view of all my clusters, the overall, my whole environment, like what are the key metrics, what's my resource utilization across the clusters? Are there any ongoing events? Like, do I have a certificate that's expiring? Do I have an error where one of the Linkerd components has fallen below 100% success rate, whatever that may be? Then I can go a little bit deeper. I can look at the control plane. When you're doing multi-cluster, your certificates, the certificates that you use need to share a common trust root, right? So in the case of East 1 and East 2 and West 1, right, I can see that they share a common trust root so that I can do multi-cluster communication in this case. I can filter on things like I could say, hey, I only care about, I could see for the control plane, I can see all the success rates across all my clusters. So if I'm trying to zero in on where I've got a problem, I can see that very quickly. The data plane, this is where we actually see the proxy. So some nice bits of functionality that we put in here. Like one, if you're running a lot of Linkerd across clusters, you want to ensure that the data plane version works with the current control plane that you're using. So here you can get a sense of all the proxy versions that you have in the environment. You can also, like, say you're concerned about a particular issue, right? So I've got one of my ambassador pods on East 2 is having a problem. I can actually click this little SOS button and send proxy diagnostics over to Buoyant. So if you need help diagnosing an issue, because like you're seeing aberrant behavior with your application in the proxy, you can just send us a diagnostic bundle instead of going in and digging into logs yourself. Today, right, what we're going to do is make it so that you can proactively alert on things inside Linkerd. What we're looking to do to extend is add in installs and upgrades that happen programmatically, as well as handle certificate rotation for you so that you don't need to be concerned about that. And then beyond that, you get this nice overview of all the workloads across your environment. We can do cool topology maps. So my infrastructure cluster, as an example, right? I can scroll in a little bit and I can see, all right, well, I've got Ambassador and it's talking to a couple different apps, right? So it's got the Emoji Voto app, and even on my infrastructure cluster, the Emoji Voto voting service is being problematic. But I can also see like, oh, we're also talking to Books app and it's having problems, but Linkerd Web is behaving great. And then, get metrics in a holistic way. I can filter. So I created, when I added my AWS clusters, right, I gave them a tag so I can see, hey, specifically for my workloads that are in AWS, what do things look like? Well, my success rate for everything is 100%. That's great. My request rate, where that sits, latency, all the statistics about your applications. So
it seems like, a lot of this is the same stuff you're getting with the normal dashboard, but at a global scale, where you can see all of your clusters, all of your regions, all of your applications, and especially with things like exported services or something that is talking across cluster, like it's going to be hard to track some of that, because you're going to basically lose tracking in one cluster as it goes somewhere else, and then figuring out like where that came in and how that got, where the error is at that rate, right?
Right. Yeah, exactly. And then, one of the other components that's really nice is if you're using Linkerd and you add Buoyant Cloud. So anyone who's using it can add Buoyant Cloud for free. If you do sign up and pay for Buoyant Cloud, you can get Linkerd support along with it, right? As well as that, like, proactive notification should something catastrophic go wrong, right? Or be about to go wrong, you'll get notified ahead of time. So that's awesome. That's kind of the deal there.
And I actually have so many more questions now for like all sorts of different things that I'm thinking of in my head of like, well, like, how do we do upgrades? Where are some other benefits for exported services? But unfortunately, we are at our time for today, so we are going to wrap up. But we might have you on again in the future because this was great. Just being able to understand how this interacts with all those different layers, just some of the default benefits of doing a quick install and like opting into a couple things and saying, "Oh, I understand it more." Was a great walkthrough.
Awesome. Well, thanks for having me. I would love to be back anytime.
Yeah. So thanks for joining us. Thanks, Jital, also for coming. This was great having your expertise on the call as well. And thanks everyone for watching. And we'll go ahead and wrap up. So
thank you, guys. And for everybody on the show, we haven't rehearsed any of this. And we had so much fun learning, Jason, as well as with our audience. So thank you.
Yeah. Have a good one.